Welcome to this explainer. Today, we're speaking directly to you, the global manufacturers, the mechanical engineers, and the procurement managers who are operating right at the bleeding edge of industrial production. We are talking about high-stakes manufacturing today, the kind of environment where overcoming severe metalworking challenges and truly mastering the physics of material removal, well, that dictates the sheer viability of your entire operation. So, let's dive right in and look at exactly how Evergreen's advanced tooling provides a definitive edge.
Let's start with a stark reality out there on the factory floor. Are tool chatter and aggressive vibration absolutely destroying your surface finishes? It's honestly one of the most frustrating, not to mention costly, industry pain points that mechanical engineers have to face daily. When you're processing complex, hardened alloys, things like tool deflection and harmonic vibrations can take a high-precision aerospace or medical component and turn it into really expensive scrap metal in a matter of seconds. I mean, it is a violent microenvironment right there at the cutting edge, and if your tooling isn't specifically engineered to handle those extreme dynamic forces, the results are pretty much catastrophic for your production schedule.
And you know the true cost of machining failure? It's never isolated. It's a cascading failure across your entire operation. Severe chatter leads directly to degraded surfaces and rejected parts. But behind the scenes, that same vibration is microchipping your cutting edge, which drastically shortens your tool life. Suddenly, your CNC machines are down for constant tool changes, and you're looking at massive lost production time. And for the procurement managers tuning in, this translates directly into skyrocketing consumable budgets and heavily inflated procurement costs. It really is just a vicious cycle of inefficiency.
Now, the solution to this cascading failure actually lies in geometry. Enter the corner radius end mill. By definition, this is a highly precision milling tool that combines an incredibly resilient solid cemented carbide substrate with a specialized rounded edge geometry. So why does this matter so much? Because in machining, stress concentration is the absolute enemy. By engineering a very specific radius onto the corner of the end mill, we fundamentally change how cutting forces are distributed into the tool and the workpiece. This isn't just some slight design tweak, it is a vital evolution in machining physics, specifically designed to optimize stress distribution and completely halt that cycle of failure we were just talking about.
Notice the highly specialized designs required to actually combat the physics of tool wear. Whether a setup is utilizing PCD tools for incredibly extended lifespans, single-blade T-type cutters for inner cavities, or specific chamfer cutters to achieve a flawless mirror effect, the geometry is always deeply intentional. Every single angle, every flute depth, and every edge preparation is meticulously calculated. This specialized milling design is exactly what separates your standard, off-the-shelf tooling from elite, high-performance industrial solutions.
Let's actually break down the engineering physics step by step. Step 1 is your foundation. The cemented carbide substrate provides immense high hardness and rigidity, which prevents the tool from deflecting under heavy loads. Step 2, the rounded edge geometry. Instead of taking the entire brunt of the cutting force on a fragile, sharp point, the radius smoothly dissipates those radial and axial cutting forces. And step 3, this creates a synergistic stress distribution. Because the force is spread over a larger, mathematically optimized surface area right on the corner, it prevents the catastrophic microchipping that usually dooms standard tools. You're getting the perfect blend of aggressive cutting capability and extreme durability.
But, geometry is only half the story. We have to talk about material science. These tools are quite literally engineered for extremes. They feature advanced coatings like titanium silicon nitride, nanoblue, and diamond-like carbon, or DLC, layered right over the solid carbide. And these aren't just for show. In high-speed machining, heat is your primary adversary. A coating like Tissin acts as a highly effective thermal barrier, keeping the intense heat of the cut trapped in the chip and out of your tool. To put that into perspective, the cutting edge experiences localized temperatures and pressures akin to a rocket engine nozzle. Meanwhile, DLC provides incredible lubricity, preventing sticky materials like aluminum from welding themselves to the flutes. This kind of advanced metallurgy multiplies the tool's lifespan exponentially.
When you compare the two, the difference in physics is just stark. On standard square end mills, concentrated stress at sharp corners creates a massive risk of chipping the very second you try to push your feed rates or hit a hard spot in the material. Conversely, Evergreen's corner radius mills offer incredibly even stress distribution. The result? Greatly extended durability, particularly when you're roughing or finishing really tough aerospace-grade alloys. By making the switch to a corner radius geometry, engineers can confidently program much more aggressive tool paths without that constant fear of sudden tool failure mid-cycle.
So let's see how this thermal resilience translates into real-world applications. When utilizing advanced materials like PCBN, the tooling exhibits exceptional hardness and high heat stability up to a staggering 1,300 degrees Celsius at the cutting temperature. 1,300 degrees! That is exactly the kind of thermal punishment required to machine today's hardened steels and superalloys efficiently. Without this extreme level of thermal stability, the cutting edge would simply plasticize and melt away, completely destroying the dimensional accuracy of your workpiece.
And this theoretical physics translates into serious manufacturing profit. Just look at the parameters. For finished machining on hardened steel under HRC 55, you can run cutting speeds of 200 meters per minute with a feed of 0.08 millimeters per revolution. Need to do some heavy cutting? You can push a feed of 0.2 millimeters per revolution at 80 meters per minute. And for finished machining on gray cast iron, an absolutely incredible 700 meters per minute cutting speed. You see, you aren't just buying an end mill here. You're buying the capability to run your spindles faster, push your feed rates much harder, and dramatically reduce your cycle times on some of the most difficult materials on Earth.
Which brings us to the specific materials this tooling conquers with ultimate stability. We are talking about carbon tool steels and mold steel, the notoriously gummy stainless steels. Hardened steels ranging from HRC 45 all the way up to 65. Exotic, high-temperature alloys based on nickel, cobalt, chromium, or iron. Even highly abrasive powder metallurgy and gray or cold hard cast irons. For procurement managers and engineers who are tasked with sourcing reliable industrial solutions across a wildly diverse range of production runs, from sticky, gummy alloys right over to highly abrasive iron, this level of versatility is an absolute game changer. It means you can standardize your tooling inventory without sacrificing an ounce of top-tier performance.
Ultimately, the Evergreen advantage can be perfectly distilled into a single, powerful guarantee. Ultimate stability and precision performance when processing the world's most difficult alloys. By combining elite cemented carbide substrates, intelligent corner radius geometry to dissipate stress, and advanced thermal barrier coatings, manufacturers can finally take full control of their machining processes. You eliminate the chatter, you extend the tool life, and you guarantee a flawless surface finish on every single part that leaves your facility.
So, I want to leave you with this final provocative thought. Can your current tooling actually survive the physics of tomorrow's alloys? The demands of modern manufacturing are only getting tougher, that's for sure. If you're ready to upgrade your production capabilities and permanently eliminate costly machining failures, I highly encourage you to take action on this. Visit evergreencarbide.com right now to request your comprehensive technical data sheet or secure a premium sample kit for your facility. Go see the geometric advantage for yourself. Thanks so much for joining me on this explainer, and keep pushing those boundaries of precision.